Did you know that the study of water waves has led us to the technology that we enjoy today? For example, Wi-Fi, which we use to access the internet, mobile phones, which are used for communication purposes. Now, these are examples of how technology uses an understanding of waves to actually perform a particular role. Now, we can't see Wi-Fi waves and we can't see the mobile phone waves, but we certainly can see water waves. So the question before us today is, how are waves produced and can they actually move objects? Now, I'm going to start by looking at an example where we have a pond of water and the water is perfectly still. And what we're going to do is we're going to imagine dropping a stone into this water. So we take a stone, we raise it, the stone therefore has gravitational potential energy. When we drop it, that's released to kinetic. It makes an impact with the water. Now, the moment the stone disturbs the surface of the water, it generates a series of ripples or waves. Now, I'm drawing two types of circles here. The circle that's a complete circle represents the crest or the top part of the wave, and the dotted line represents the bottom of the wave. So if we're looking at it from this top view, so this is our top view, we can actually see the waves moving out like a series of fronts. So the waves are moving out from the center of this disturbance. Now, we've used the word disturbance because obviously the water surface has been disturbed. So the word disturbance actually means force. So disturbance actually means force. In fact, it is the term used to describe the force that generates any wave motion, whether it's the waves generated from an antenna or the waves generated from a device that produces a Wi-Fi signal. So the disturbance in this case is a force, and it's the force of impact of the stone with the water. So the stone and its force of impact disturbs the water molecules and they begin to move up and down, generating the wave. If we now consider the side view of these waves, so we're now going to consider the side view, and let's say that this line here represents the undisturbed water surface. So we're looking at it from the side now rather than from the top. Then, as the disturbance generates the waves, we see something that is more wave-like. So here we have our crest, and of course we have our trough. So the top of the wave is called the crest, the bottom of the wave is called the trough. Now, we want to understand what's moving and how it's moving here. How is the wave moving? How do the particles in the water move? These are the things we need to understand. So let's assume that we've got a float. It's floating here on top of the wave, and we're going to observe this floating object as the wave moves to the right. Now, because the wave is moving to the right, then we know that this wave has energy. In fact, that's the energy of movement, which we call kinetic energy. So this wave has kinetic energy as it moves to the right. Now, the particle that's floating on top of the wave, what's it actually doing as the wave passes? Well, let's consider that. So if we take a snapshot of the wave at some time after we see it in this position, the wave might move something like this. Now, the wave's moving to the right. What have we got? What's the particle doing? Well, the particle has now moved down into this position. So the particle is actually moving down. Let's take another frame. At some time later, if we follow this pattern, and in this particular case, you can see that the particle has moved down even further. So the first thing we can conclude is that the wave moves to the right, the particles in the water are moving up and down only. So when we're talking about a wave, in this particular type of wave is called a transverse wave. So the word transverse means the particles of the wave are moving at 90 degrees to the direction of the wave. So a transverse wave is simply a wave that moves in a particular direction horizontally, but the particles are moving up and down as the waves come through. Now, let's think of a practical example. Most of us have been to the surf, and one of the great things about summer and going to the surf is that we like to jump into the surf and we like to play in the surf. We like to play with the energy. Now, if this model tells us that if this float is a surfboard or a person on a surfboard, are they moving up and down? Well, yes, they are. So therefore, how do you catch the wave? How can you actually move with the wave? Well, you can't sit on top of the wave. So what you've got to do is you've got to catch the slope of the wave. So you have to get slightly ahead of the wave and ride the slope down the wave, and as the wave moves to the right, you're always going to be riding the slope. So that's the same as riding a skateboard down a hill. So in summary, how are waves produced? Well, waves are produced by a disturbance. So anything that disturbs, for example, water will generate a wave. Other things that have the capacity to disturb water are things like the wind, and also things like tides. So the energy sloshes backwards and forwards as a disturbance causes the water to rise and fall. Can they move objects? Well, yes. Here is an example, the surfer being moved. So these waves do have energy and they can apply force. So as a consequence of that, they can move objects.